Hi, everyone. We're looking at the next unit, which is all about polygons. So first off, we're going to talk about the angles that happen with polygons. And in order to do that, we need to make sure we understand exactly what a polygon is, because not every shape out there is considered a polygon. So specifically, a polygon is a closed figure with segment sides and it cannot have anything curved, hence why it's made up of segments. Segments are straight pieces of a line, so no curved parts. So sorry to say, a circle is not considered a polygon. All right, let's talk about some of the other properties and vocabulary that we're going to be looking at with our polygons. The next one is a regular polygon. Now, specifically, a regular polygon is a polygon that has all congruent sides and all congruent angles. So all of the sides are exactly the same length and all of the angles are exactly the same size. So that could be called an equilateral, equiangular polygon. But instead of saying equilateral, equiangular, we just say it's a regular polygon. Now, while we talk about the angles inside of a polygon, we're also going to visit the angles outside of them as well. But we'll start on the inside and see how do we find the measures of the interior angle. So this first topic, whoops, I'm going to make that just a little bit bigger. This is the sum of the interior angles, which means if we add up all the angles inside that triangle, what total would we get? Now, these are for regular polygons. Well, I'm sorry, not this formula. One of our formulas are for regular polygons. Specifically, this formula says that first off, we need a variable, and so we are going to use the letter n. So n for us, and I'm going to zoom in here, make this a little bit bigger. So for our formula, n is the number of sides. It could also represent the number of angles because we do have the same number of sides as we do angles. So let's change that to an or. So the formula that we're going to be using says that to find the total, we are going to do 180 degrees times n minus 2. So 180 times the number of sides the figure has minus 2 from that. And so we're going to see some examples of how that works here in just a second. All right, so example 1 says, what is the sum of the interior angles of a hexagon? So first off, we need to remember how many sides does a hexagon have? So that means it's got 6 sides. For the prefix there, hexa. So if our figure has 6 sides, that means n is a 6. So the sum of the interior is going to be 180 times 6 minus 2. So 6 minus 2 gives us a 4. If we keep going step by step here, we have 180 times 4 for a total of 720 degrees for the total sum of a hexagon for the interior angles. Now, one of our other formulas that we have is sum of the exterior of any size polygon. And for that, does not matter how many sides. Oops, sorry, that's a little hard to read. So the number of sides doesn't matter because it is always 360 degrees. No matter if it's a triangle, a square, a hexagon like what we just saw, or a figure with 20 sides. If we're looking at the sum of the exterior, no matter the size, it is always 360. So in example 2, what is the sum of the exterior angles of a hexagon? Again, it does not matter that a hexagon has 6 sides. It is always 360. So a hexagon would have 360 degrees for the sum of the exterior. Now, some of the other formulas that we're going to be working with is to find the measure of one interior angle of a polygon with n sides. So again, one thing I said earlier is that n could stand for one of two things. N could be the number of sides, or it could represent the number of angles. Because again, the polygon has the same number of sides that it does angles, just like a triangle has 3 sides and 3 interior angles. So what we're going to do is use that same formula we saw earlier to get the total inside, which is 180 times n minus 2. And then I'll go back and divide that again by n. Because again, the number of sides and number of angles are the same. So let's practice how we use this formula now. What is the sum of one of the interior angles? Sorry, sum should not be there. It should be what is the measure. Sorry, that should be measure. And is what is the measure of one of the interior angles of a regular hexagon. Now that is something we must be specific about here, because again, to deal with one interior, the shape must be regular to use this formula. Okay, this figure must be regular. And notice that's what it's told us here. Again, the hexagon has 6 sides and 6 angles. So we'll plug that back into our formula, 180 times 6 minus 2. And then we'll go back and divide it by the number of sides or a number of angles, which is still 6. So we said earlier from the example 1 that 180 times 6 minus 2 was 720. And I'm going to divide this by 6, which means each interior angle of this hexagon is 120 degrees if it is a regular hexagon. All right, example 4 does our next formula. What is the measure of one exterior angle of a regular polygon? So again, one exterior as long as it's regular. So we already saw that the sum of exterior was 360. So if I divide that by the number of sides or number of angles, I can figure out what's going on at one exterior. So let's see what happens. What is the measure of one exterior angle of a regular hexagon? All right, so again, hexagon means there are 6 sides or 6 angles. So 360 divided by 6 means each exterior angle is 60 degrees. All right, so now that we've talked about how we find the angle measures inside these figures, let's look now and see if we can use some of this information and work backwards. So this example we have, if a regular polygon has a sum of the interior of 1080, how many sides does it have? So again, if they're giving me sum of the interior, that is 180 times n minus 2. So 180 degrees. Sorry, I'm going to zoom in here. Make that a little nicer. 180 times n minus 2 is supposed to equal 1080. So let's work backwards and solve this. All right, so first things first, let's take care of the 180 that is in front of those parentheses. So instead of multiplying by 180, I'm going to divide it out. So I'm left with n minus 2 on the left. And let's see, 1080 divided by 180 is a 6. Now we can keep solving this. Let's add that 2 back over. And so my number of sides is 8. And so there is my answer. Find the number of sides if I know the total. So again, working backwards. So let's use all of these formulas and see how we can use each one for your different size of figure. Now, they all revolve around the triangle, hence the 180 degrees. So for the triangle, we already know the sum of the interior angles is 180. That's a given. So I'm going to make that just a little bigger. We looked at that first semester. Find each interior of the regular polygon. So we're going to take that 180. Again, my n is 3 because it's a triangle. So 180, and we'll divide that by 3, which means each interior of a regular triangle is 60 degrees. Now let's do the sum of the exterior. Well, like we said earlier, sum of the exterior is always 360. Does not matter the size. And to get each of these, 360 divided by n, in this case 3. So each exterior would then be 120 degrees. So we can work through and get a lot of information just by knowing how many sides our figure has. All right, let's try quadrilateral, which means, if you remember from middle school, n is 4. So now we can use our formula. 180 times 4 minus 2 is 360. So to get each individual angle, if they're all the same, 360 divided by 4, which means each one is 90 degrees. Now, because it doesn't matter the size of this shape, again, the sum of the exterior, 360. To find one of those one of those exteriors, 360 divided by 4, which means I have 90. Let's keep going. All right, our pentagon means n is 5. So 180 times 5 minus 2, which gives us 540, excuse me, for my total sum, 540 divided by the number of sides, which is 5, means each interior angle is 108. Again, each of these are giving us this next box. Now let's do the same thing with the exteriors. Again, no matter the size, total exterior always 360. So then that 360 divided by the 5 angles it's got means each exterior angle 72 degrees. Let's keep going. All right, now we have the hexagon. Hexam again meaning 6, so n is 6. So I'm going to make that just a little smaller. If I could actually hit the eraser, there we go. All right, so our n is a 6. So 180 times 6 minus 2. Let's see what we get. Is 720. Take that same 720 and divide it by 6, which means I get 120 for the interior angle. Now let's do, whoops. Sorry, that 120 is supposed to be in the next box. All right, now let's do the exteriors. Again, it does not matter the size. The sum of the exteriors is always 360. We take that same 360 and divide it by the number of sides it's got, and each exterior is 60 degrees. All right, our next one down, a heptagon. So this is one that you might not recognize. It doesn't get used as much, but a heptagon, for hepta, means you have 7 sides. And so we're going to do the same process that we did with the others. Again, to get the interior, we'll do our same formula. 180 times 7 minus 2. Means that it has a total of 900. Take that same 900 and divide by 7 for its 7 angles. Now this one we do get a decimal for, and sometimes it's going to happen. So it will give us approximately 128.6 degrees. I'm going to round that off to the nearest tenth. It's actually 0.57, which again, since to the nearest tenth, rounds up to 0.6. All right, exteriors for these. Again, doesn't matter the size, always 360. So that same 360 divided by 7, and again, it's probably going to give us another decimal. Which means each exterior angle is about 51.4. And again, I'm going to just round to the nearest tenth of a degree. So 51.4 degrees. All right, moving right along. Another one that is popular to use, especially when driving, is the octagon. Again, octa meaning you've got 8 sides, very much like an octopus has 8 tentacles. The octagon is the shape that's used for the stop sign when you're driving. So we're still going to do our same formula, 180 times 8 minus 2. Which means we have 1080 For our total interior, we're going to take that same 1080, divided by the 8 sides our figure has. So each interior is actually a nice, pretty 135 degrees. No decimals here. Now let's do the exteriors. Again, 360 for the total exterior. We're going to take that same 360 and divide it by the 8 angles this shape has. Which means each exterior is about 45 degrees. All right, moving right along, we're almost done with our commonly used polygons here. The next one is the nonagon, next in list. So that means you have 9 sides in this shape. This one's not used quite as much, but it does get used. So 180 times 9 minus 2, which means we have 1,260 degrees for a nonagon, all the angles added up. If we take that same 1,260 and divide it by the 9 angles it's got, each interior angle of that regular polygon, 140 degrees. All right, so one of our last ones that we're going to work with in this table, just to make sure, again, we get familiar with it, is the decagon, which means we have 10 sides. There it is. Sorry, lost my marker for a second there. All right, so 180 times 10 minus 2. Means that the total for a decagon, for its interior angles, whoops, sorry about that. There it is 1,440 degrees. Take that same 1,440 and let's see what's going on at each one. So 1,440 divided by the 10 sides that it's got. Means that each interior is 144 degrees. Oh, sorry, forgot my last 2 columns here. For both of these, the nonagon and the decagon, your exterior is 60. If we finish up this row right here for nonagon, we'll take that same 360 and divide it by 9, which means each exterior would be 40. And then we'll do our last one here. Again, 360 for the decagon for the exterior. So 360 divided by the 10 angles that it's got means that each exterior would be 36 degrees. Now, there are 2 other triangles that do get used when we deal with your interior and exterior angles. They're just not listed here in the table, but we do need to be aware of their names. So one of those is the decagon, and I'm not going to go through the whole table with this one, but just to write it out so that we remember its name and how many sides it's got. The decagon means that your n is 11 for 11 sides. And then we have the dodecagon, which means you have 12 sides. Now, anything that is more than that, so 13 or more sides, we use how many sides it's got, and then we put gon at the end of it, meaning a 13-sided shape is a 13 gon, a 14-sided shape, a 14 gon, and so on and so forth. So like a 13 gon, 14 gon, and so on. It just depends on how many sides does it have. All right, so our last example is what happens when our shape is not regular. How can we still use the polygon sum theorem to find our missing pieces? So this last example does exactly that. We are going to solve this figure first for x, and then we'll find the measure of each individual piece here. So first things first, how many sides does this have? I need to know what n equals. So let's count up your angles or count up the sides. Either way, you get the same piece. So we've got 1, 2, 3, 4, 5 sides. Let's get your total interior first from that. And that'll tell me what to do with all of those expressions. So all 5 of these expressions, or all 5 of these angles, I should be able to add them all up. How many is that? That's 4 blanks. And set them equal to the total. And again, if I have 5 sides, I'm going to go into my Desmos real quick. Once I can find where it is, there it is. Sorry about that. Wrong Desmos, don't need graphing. There it is at the end. So 180 times 5 minus 2 means my total is 540. So for us to figure out what the value of x is, we need to add up all of these angles. So let's start down at A. It doesn't matter exactly where we start, but let's start at A, 4x plus 10. All right, if I look at B, 6x plus 10. Then we have C, 5x minus 5. D, 4x plus 5. And then our last one, E of 7x. So we have one long algebra problem here. So first things first, we need to combine all of these like terms. So let's start with your x's. We've got a 4x, 6x, 5x, another 4x, and 7x. So 4 and 6 make 10. 10 and 5 make 15. 15 and 4, 19. 19 and 7, 26 x's. Okay, now we have combined all our x's. Now we need to combine the constants, the plain numbers. So we're looking at the 10 plus another 10, so that makes 20. 20 minus 5 puts us at 15, plus another 5, which puts us back to 20, and there is no constant with the 7x, so we are at a plus 20. And that is still supposed to equal our total down there at the end, 540. Now we have an equation that we can solve. All right, so we can now subtract that 20 from both sides of our equation. So 26x is going to equal 520. Now we can divide both sides by 26. Which means my figure has 20 sides to it. So guys, that means x is 20. So now I can use that 20 and see how many degrees are at each of these different angles. So let's start at angle A. So if the measure of angle A is 4x plus 10, now we know x is 20. Let's plug in the 20. So 4 times our 20, and then we're going to add 10 to that. So we'll plug our 20 in. So that gives me 80 plus 10. So the measure of angle A, 90 degrees. Now let's do angle B. So the measure of angle B, let's go back up and make sure we have its equation, 6x plus 10. So 6 times our 20, and then we'll add 10 to that. So we need to plug that in. So 120 plus 10 means that the measure of angle B, 130 degrees. Let's do C now. All right, C was 5x minus 5. So the measure of angle C, 5x minus 5. So 5 times our 20, and then minus 5 from that. So 5 times 20 is 100. 100 minus 5 means the measure of angle C is 95 degrees. 2 more to go. The measure of angle D, let's go get its equation. 4x plus 5. Okay, so 4 times our 20. And then take away 5. So 4 times 20 is 80. Minus 5 means the measure of angle D is 75 degrees. And then our very last one, E, because there were only 5 of them. The measure of angle E said the equation was 7x. So we need 7 times what we got, which was our 20. So then the measure of angle E is just 140 degrees. So if we add up all 5 of these total values that we found at the end, 90 plus 130 plus 95 plus 75 plus the 140 at the end, all of those would add up to the 540 total that we initially found. Okay, guys, I hope you enjoyed learning a little bit about the angles inside polygons. Please don't hesitate to reach out to me if you have any questions at all. Bye, guys.